whereby I've worked out a resultant force. Sorry, I think my audio was not working, but now it's whereby I've worked out a resultant force. Sorry, I think my audio was not working, but now guys, if you are taking AS physics, I would like you to be active in the chat section so that I can be able to know those who have joined us. Okay, let me get to know those who are joining us. And so as I was saying, the first thing that you need to do in this question here is to find the resultant force. And basically the resultant force is going to be 1600 minus 1200. Now that is going to translate to our resultant force. So then we can be able to apply the formula: force is equals to mass times acceleration, because we are supposed to work out the magnitude of the acceleration here. So we are going to say acceleration is equal to the resultant force divided by the mass that we are given. So this is going to be 400, then divide by the mass, which is 850. So if we work it out, we are going to get our value as what? So we need to work this out. We are going to get 0.47, and that is going to be option A. So that is what you are supposed to do in this particular question. But the most important part is for you to ensure that you remember this kind of formula: force is equals to mass times acceleration. So if you are taking the paper tomorrow, let me get to know whether you are ready. Guys, please be active in the chat section so that I can know that we are moving together. And if there is any question, let me get to know. Let's look at, so we have said this one, the correct answer for that is well stated there. Okay, so moving to question number 3. Question number 3 says an object of mass m is suspended from a fixed point, and then we have the spring here, and then the mass. The spring has a spring constant k, and the object is set into vertical oscillation with period t. And then which equation of t is homogeneous with the base units? And that is going to be, that is D in that case there. An object of fixed mass initially at rest at point P, the object then moves away from point B with uniform acceleration. So we are looking at a scenario whereby initially at rest at point P, and the object then moves away from point B with uniform acceleration. Which statement describes the resultant force acting on the object? Which one? So we are going to say the force is constant since the object is accelerating. So we can say this, the force is constant since the object is accelerating. And then this is constant but not what? 0. So that is exactly what we're going to say at that given point. Moving to question number 5, a projectile is launched at an angle of 25 to the horizontal with horizontal component of velocity 13 meters per second. What's the vertical component of this? So having that is launched at an angle, so we're going to say if it's launched at an angle of 25, then this is going to be 13, and now we are working out the vertical component, and we are going to say this is going to be tan 25 is equals to u in the vertical direction of 13, which is adjacent, and then we can say now u in the y direction is going to be 13 tan 45. Now if we put that in the calculator, we're going to get our answer equivalent to b, which is 6.1 in that case. What is the displacement of the ball? Remember, displacement, we are going to work out the area in this region and also the area in this region, then we add the two together, and that is going to be a half times the base, which is 1, times the height, which is 10, and this is going to be 5 meters, and working out this one is going to be a half times the base, which is 0.5 times -5. So if you work it out, you are going to get the distance becoming what? Yeah, so the answer you'll get working out this, it will be minus plus this answer, which is going to translate to B. Yeah, so this one, because it's displacement, we are going to consider the area that we have below the x-axis as negative area. So if you take the answer you get here plus negative of this answer, you're going to get your answer as that.
Which shape is this?
That's a parallelogram.
What is the area of the shaded regions in the figures below? Sasa hapa tafanya vipi? Area of the shaded region.
Is 90 degrees here? It is 90 degrees.
Kuna kitu imeandikwa hapa. 31.
From where to where?
20. I think from here to here.
From where to where?
Here to here. Here. 31 from here. Here 20 from here. From here 43 from here to here.
How can it from here to here be 31? unless from here to here is the one that is 31.
And from here to here.
Oh, that will be that 43.
Huh?
It will be from here to here, it be 43 minus 31 utapata hapa hivi.
43.
Minus 31.
Sielewi.